Okay. Okay. Hi, everyone. My name's Mike, and welcome to the 3M Digital Print Production Training course. So today I'm joined by Cohen from Computer. He's the IT guru who will make sure everything runs smoothly. Michael Holderness, technical trainer from 3M, and also Kim McKee, the North Island rep, is with us. And I think Arlette's hanging around just to make sure it all goes smoothly. So today, Michael will be taking you through the wide format basics, things like media handling, environmental concerns, printer and rip operation, color management, profiles, troubleshooting, etc. And just some housekeeping. So everyone's muted, but feel free to use the raise hand function at the bottom, and we can and then you can ask a question there. We'll let you speak, or use the Q&A function at the bottom. We'll monitor that throughout and do our best to answer it. And also there'll be sort of 10 minutes or so at the end to give everyone a chance to ask anything that they weren't sure about. So apart from that, I think that's all good. John, I'll hand it over now to Michael Holderness.
Right, we'll kick it off. I'll just share my screen with you. Right, 3M Digital Print Production Training. This is an online version of the course that we run in person. It is an abridged version. If you do come along to the course, you will obviously get quite a bit more, but it will give you a good idea of some of the basics that we go through. Most important thing to remember with this is that this is generic. It is generic to digital printing. We won't be covering one particular type of printer in preference to the others, because we need to cover all types of printers in this. We will be finished just before midday with a little luck, so we should have a bit of time at the end for questions. But as Mike was saying, feel free to raise your hand or ask a question in the Q&A. Really what we're looking at is the whole purpose of this is to get more out of your print and media and understand your printing process, and to overcome some common problems that people will see. What I've always had from this, whenever I've done this course, is I've had a lot of people reluctantly come along to the course saying, oh, I know how to use my printer. I don't know why my boss has told me I've got to go. But not one person has ever come out of this course saying they didn't learn something. There's so much in here for everyone. We cover a massive variety and range of topics. So that even if you're an experienced digital printer, you probably get something out of this. So the agenda is we'll talk about the print process, then we'll talk about the printer environment and media storage and handling. Then we'll talk basically about printers and rips. Then there's a section on color management, which is quite important for getting the best out of the process for your customer. Then a brief section on printer maintenance, and then everyone's favorite section, troubleshooting, what went wrong and whose fault was it. Kicking right into it, the digital print process. What we've got here is going back to the days of the ARC. We started off with 3M started off with an electrostatic printer. This is basically like a great big photocopier. For those of you that have been around forever like me, you'll remember this printer. The 3M had one called a Scotch Print 2000, and that was an electrostatic printer. It was not particularly high resolution, so these days it would be considered to be primitive, but billboard-sized stuff, you can't tell. It still looked good. But the beauty of this was it created one of the most durable prints that I've ever come across. We supported this printer from the late 90s through until the mid 2010s. So we only stopped supporting this probably about 5 or 6 years ago. That's one hell of a run for a printer. The only reason it was supported this long was that it was authorized by Boeing and Airbus to be the printer of choice for doing digital graphics for aircraft. So we've had one of these in New Zealand for many, many years, printing aircraft graphics, and it's only just been retired about 6 years ago. So created a really great image. But the way it worked was essentially like a big photocopier. So you needed a thing called a transfer media. So you needed some special transfer paper that went in there as well. It took a toner and electrostatically stuck the toner onto the transfer medium. And then you, in a second process, you would laminate the transfer medium to the film, and it would transfer the toner to the film. So it was quite an archaic process, but it did a really good job, created a really durable print. Then the next sort of printers that we had were thermal transfer printers. The best example of those are if you go into, when they're open, a New Zealand Post shop to get a new license label for your car. And the thing whirs and clicks and they rip off a license label and they hand it to you. And your little label with the black image on there is a thermal transfer label. Basically what it's done is inside is a head with a whole lot of spots that get very hot on it. And over the top of that head is either a wax or a resin ribbon, and then your media underneath that. And the thermal transfer head will heat up a spot on the ribbon and fuse it into the label underneath. Not commonly used for wide format stuff. For those of you, once again, that have been around a while, and I know there are still some out there, the Gerber Edge is a thermal transfer printer. So if any of you have come across a Gerber Edge, or some of you may have a Gerber Edge, that's a thermal transfer printer. The trouble with the Gerber Edge is they were only about 300 millimeters wide, so they're only narrow. So if you were doing any big graphics, you had to tile it with lots of strips, and it was always a bit of a pain for everybody. There was a wide format version of that that came out of a company called Matan from Israel that had one 1220 wide. The trouble though is a little narrower ribbon may be cheap, but a ribbon 1200 wide is exponentially more expensive. So you're talking thousands of dollars for each of the ribbons, and you'd need a minimum of CMYK. So many thousands of dollars just to put the ribbons into the printer. So it was never that successful. That brings me on to the inkjets. The first of the inkjets was the thermal aqueous inkjet. And what this did is it took a liquid-based ink, heated it up, and spat it onto the surface of the media. Great technology, worked well, wouldn't want to put it outside. If you put it outside, it would fade, and it would fade very quickly. So anything made with an aqueous thermal printer outside may have lasted probably no more than 6 months. That brought us on to the piezo printers. And that's essentially what we're talking about. That's why I've got a big red ring around it. Those are the printers that we're using today in our industry. The first of them were the solvents, and they were the ones, if you've been around a while, sit beside a solvent print and you'd end up with a heck of a headache because the solvent from those was just horrible. So then they quickly went on to eco-solvents. So the eco-solvents were much more mild solvent. They still did a really good job, and there are a lot of eco-solvent printers out there today. I've got an old Roland in my lab, an old eco-solvent printer. There are still a lot of eco-solvent printers that are being used. Then we went on to UV curable printers. That's where we lay an ink down and we cure it with a UV light. They're very common these days. We've got a number of those around. And then finally aqueous. That's our latex print. So the latex printer is an aqueous piezo printer, and we'll talk more about how that works later. So as we see the rise of the latex printers, they're all also in this piezo area. So how do piezo printers work? Piezo printer works, and excuse the quality of the image. This is the best I could find. A piezo printer works because there's a little crystal inside here. When you put an electric charge around the crystal, it will change shape. So what's happening here is that when you put the charge on this way, it changes the shape of the crystal. It pulls up on the membrane and sucks ink in from the reservoir into this chamber here. Then when it reverses the charge on the crystal, it changes the shape of the crystal in the other direction, and it pushes down on that membrane, and it pushes the drop of ink out of that little holding chamber. Then when it turns the charge off, the ink droplet falls off and heads down towards the surface of the media. So that's how it works. It's using an electric charge to suck in and drop out a drop of ink. The ink droplets are measured in picoliters, which is 1 to the 1,000, very small droplet. Excuse me. And as the years go on, this number gets smaller and smaller. The ink droplet size gets smaller and smaller as the resolution increases. So that's how the piezo inkjets work. All of them, the latex, the UV, and the solvents, all use the same type of technology in the head. How they do it is very much up to the printer manufacturer, what types of heads they use, but they all work on the same principle of using a piezo crystal to change the shape and squirt ink out of this chamber. Brings me on to a thing that we're not going to cover this anymore, except to say that we just need to talk about it. The ink droplets are easily blown off course by air currents, so you want to avoid air ducts and fans. If you've got covers and things on your printer, leave them on your printer, please. Don't remove them. I've seen a number of people over the years that take the covers off and wedge bits of paper into the mechanism to make sure that the printer, that it thinks the cover's there. Oh, we do that because it's easier to get to the media. Yeah, it's only going to cause you problems. A little bit hard to see from this image, but if you look here, what we've got is just around here, the ink is not looking that good. It's, you're getting a bit of shadowing from the ink, and in here around the 9, yet on the 10 it looks great. This was done by my colleague Chris in Australia, and he gently blew under the print head while the printer was printing, just to simulate what happens if you take off the covers and you've got airflow under there. It'll blow the ink drops off course. It's not rocket science, guys. Keep the covers on. It's going to make life easier. Your printer's going to print better if you leave the covers in place. They were put on there for a reason. Another thing that we need to talk about, and these are just some general things that we need to cover first. The next one is called dot gain. Ink drops will spread out when they land on the media. So a different substrate will absorb different amounts of ink, and that will change your dot gain. The best way to think of this is if you print on your printer with paper, you're going to get a very high dot gain. The ink's going to land on the surface and get absorbed into the paper, and it's going to give you a big looking dot. Yet if you print on vinyl, you're going to get a much smaller looking dot. The dot's going to land on the surface and won't soak in nearly as much. So for example, your vinyl, your dot gain may be here, but paper, your dot gain will be down here. So never ever print something on paper and give it to a customer as a proof. It will look completely different to printing on vinyl. So this is just something you need to be aware of. Different substrates will absorb different amounts of ink. Different printer types will have a different dot gain as well. So the dot gain on a UV printer will be quite different to the dot gain on a latex or a solvent printer. So just bear this in mind. We're not going to cover it again, but just something to keep in the back of your mind. Brings me on to ink chemistry. The 3 different chemistries that we use in piezo printers. The first one is solvent. This also covers eco-solvent. How it works is it cures by solvent evaporation after printing. So basically what it is it's a solvent suspending a pigment. So when it lands on the surface, the solvent has to evaporate out, leaving the pigment behind. The solvents are great because they actually key into the media. The solvents will actually bite into the vinyl and bring the pigment down into the surface. And you can often see that. So those of you with a solvent printer that have maybe you've got a drop of ink where you didn't want it, or you've had the head wipe slightly on the surface and you want to use the print, you want to see if you can wipe it off. So you use some solvent to wipe the ink off. Often you'll wipe that off and you'll end up with a little bit of a brown stain behind. That brown stain is where the ink has actually already keyed into the media. It's down below the surface of the vinyl, or it's embedded in the surface of the vinyl. The solvent did that. The solvent sucked that pigment down into the surface. The issue with solvent inks is that we have to dry off that solvent, and drying off that solvent can cause us some issues. A solvent printer, you should very, very seldom use a print straight off the printer with a solvent ink. There are some scenarios that we'll cover later with that, but essentially if you're running a solvent printer, you need to let your print dry before you use it. Now the next one, the UV curable inks, these work by exposure to UV light. So your ink gets dropped onto the surface and then a light comes along behind it, very strong UV light, and that immediately cures the chemicals that are in there and it will harden the ink. So that curing process will bind the pigments. So that liquid immediately becomes a solid when it's exposed to UV light. The trouble with UV inks is that they don't tend to bite into the surface very much. They tend to sit on the surface. Some of the first UV printers that were out there, the ink sat on the surface, and if you tried to stretch it around when doing something like a vehicle wrap, you could crack the ink, or in some cases, you could actually even get the ink chipping off the surface. So they didn't have a very good reputation for doing vehicle wrapping. That's changed a bit. I know Mamaki have got some pretty good UV printers these days that give you a pretty good print that you could still vehicle wrap with. So things are changing in this space, but generally UV curable inks will be sitting on the media surface. They will have a much rougher texture. You'll end up with quite a lumpy ink textured surface because the ink doesn't get much of a chance to settle down. Now, the last one in here are latex inks. These cure by evaporation of water and co-solvent. So a latex ink is a mixture of water, some solvent, and pigments. To be a latex ink, I think the definition is it can't be more than 30%. It has to be more than 70% water. So therefore, 28, 29% solvent and about 2% pigment. So they're very high in water. The ink does sit on the media surface, but the addition of those co-solvents helps to get the pigments to get into the surface of the media. The latex print, luckily, will cure on the printer. Latex printers run hot. They run a lot hotter than solvent or UV printers. UV gets hot mainly because of the UV lamps, but latex printers are heated, specifically heated to dry off the water. So it's not unusual for a solvent printer to be running at 50 or 60 degrees, yet a latex printer to be running up 100, 110 degrees. So because it has to be hot enough to get the water to dry off. So those are the three different types of chemistry that we're using in the printers. Then you can see why I can't be specific about particular types of printers because we've got so many different types of printers and technologies. That brings me on to the print environment and also media storage and handling. We'll actually start off with the media storage. I would strongly recommend that you store your cartons of media in their original boxes. Store them horizontally and keep them up off the floor. If they sit on the floor, they'll pick up moisture. They'll pick moisture up off the floor very easily. Even if they're inside, they can still pick up moisture off the floor. We don't recommend storing your rolls like this. If you store your rolls up on the end, what will happen is that the adhesive in there, and for those of you that were listening to this course yesterday, we were talking about adhesives. And adhesives, what did I say in that course? That they're a thick liquid. They are actually still a liquid. So what happens if you store a roll on its end? That liquid or that adhesive will flow to one side of the roll. And it's not unusual for a roll that stood there for a few weeks or a month or so, and that's not unusual sometimes. Put this in your printer and suddenly you're having problems because you've got one sticky edge. The adhesive's flowed to one edge and has gone all sticky. It may be enough to cause you problems with your print head, or it may be just enough to leave adhesive all over the rolls inside the printer. So that's why we recommend do not store your rolls on end like this. You're going to just be asking for trouble. Now in use, we still recommend using something like this. This is called a pin rack. We recommend storing your rolls like that. Either keep them in their original boxes or store them on a pin rack like this. This is the best way of storing them. It's going to, the media will last better. Now, this is not ideal, but a lot of people do it. They will store them on their edge beside the printer. I'm as guilty of this as anybody. The media I'm using more commonly will be standing on its end beside the printer, but that's because it's stuff that's being used regularly. The reason why we say this is not ideal but okay is that it's generally, if it's out there by your printer, you're going to be using it fairly quickly. So you're still going to get a slightly sticky edge the longer they sit there, but with a little luck, you're using it quick enough for it not to be a problem. You also want to be careful when they're in these racks that you don't damage the edges, because if you damage the edges, you'll have trouble pulling it through your printer as well. Now that last one, dispose of the first ½ meter of film when loading to avoid contamination. Everybody laughs when I say that because nobody's going to give away half a meter of film every time they want to load the media. It's just not going to happen. So The reason I say that I'd recommend doing this, I remember many years ago, we had a printer here out in West Auckland who was having no end of problems with contamination. So they rang us up and the distributor, and we went out and we had a chat to them, and we asked all the right questions, and we were getting really weird answers. They were saying, oh, it must be your fault because it only happens on 3M film. It never happens when we use anybody else's media in our printer. So, and then the more we talked about it, they were saying that it only ever happened for the first, half meter or so of film, and then the problem went away. And this was back in the early days of digital printing, and his printer was out in the factory. So it was out in the workshop with everything else. It wasn't in its own room. It didn't have any sort of controlled environment around it. So I started to ask some questions, and I said, who are your neighbors? And the guy sort of thought I was absolutely weird. And he was saying, what do you mean, who are my neighbors? And I said, oh, just tell me, who's here? And he said, oh, there's a bakery next door on one side, and on the other side, there's a car groomer. Ah, car groomer. Here we begin to learn a few things. Turns out the more we asked questions, the more we discovered he only had problems with the first half meter of film. He only had problems with it in the morning when he first came in, or when he first started to use the printer. He only had problems in the summer when it was hot and he had his roller doors open. And what we found out was that it was actually contamination from silicon from the car groomer next door. So in the summertime, when everyone's got their roller doors open, the car groomer was spraying silicon onto the tires of the cars next door outside because it was warm, and it was wafting in on the breeze and landing on his printer overnight. So when he started up the next morning, that first half meter was contaminated with silicon from the car groomer next door. Who would have thought? That's why we tell people to dispose of the first half meter when you're loading, to avoid contamination. It does happen. Very few people will do it, but if you are having issues with contamination, this could be your issue. The reason why it was happening with 3M and not anybody else's, he generally used 3M, and it was usually the one that was loaded into the printer. So that's why it was loaded into the printer overnight, and that's why he was having contamination problems with it. Brings me on to acclimatisation. Allow the media to reach the same temperature as the print room. It avoids heat or condensation issues. We recommend at least 12 hours. So generally what we'd actually recommend is store your media that you go either that you're using or that you're getting ready to use. Bring the roll into the same room as your printer. Acclimatize it to the same temperature as the printer. That's quite important. You will end up with all sorts of issues if your print media is much hotter or much colder than your printer. You'll need to adjust all your settings to cope with that. And you can avoid a lot of that just by keeping it acclimatized, keeping it next to the printer. I've got a lovely story about that one. Back in the days before everybody had printers themselves, they'd use print bureaus. So there'd be companies around that would print for everybody else. And there was one down in Dunedin, and they rang me up and said, Michael, we've got no end of problems with non-wets. Non-wets where the ink just doesn't want to stay stuck to the surface, it just pulls away. And so we went through all of the common things, and he answered all the questions correctly. He knew what he was doing. And he said, look, it's been a real problem. And so I said, okay, I'll ship you another roll from what I had in my storeroom, and we'll just see if that solves the problem. So the next morning he rings up and says, yeah, I've got this roll in here and I've put it in and I'm printing it, and it's just the same. The problem's the same. So, well, that's really strange. Well, it can't be a media problem because they're out of two different batches. So I said, where's the roll that you were having problems with yesterday? And so I was sitting here beside the printer. I pulled it out and left it beside the printer. And I said, okay, chuck that back in and start printing and call me back. He phoned me back about 10 or 15 minutes later and said, my God, you're a miracle worker. You fixed it. It's working. Well, I didn't do anything. It was just a matter of acclimatization. It just needed time to reach the same temperature as the printer. The first roll he had was cold. It had just arrived. The second roll had just arrived on the courier overnight and was probably sitting on the warehouse floor somewhere and would have been freezing cold. So he solved his problem by acclimatizing his film. So that's why it's quite important to keep your media in the same environment that you're going to be printing it in. Printers are designed to operate in very specific environments. Inconsistent environments will give you inconsistent prints. So check your user manual. A good example of that is that a printer likes to be in an air-conditioned office where you are. It likes to be in the same environment that you're in. So what I'd say for this is you want your printer to be in the same conditions. If you're warm and comfortable, your printer will be warm and comfortable. Printers like to be at around 20 degrees, and they like relative humidities of around 50 or 60%. If you get the temperature up too high or too low, or if you get the humidity too high, you will end up with printing problems. There was one company in Auckland here many years ago. They had a lot of digital printers, and I'm talking sort of like about 10 different printers doing different jobs. And they were in a big factory. They had no way they could air condition that. And they had no end of problems. Like if they got a job in the wintertime, they'd document all the settings they used to create it. The customer would come back 6 months later and want another copy of the print. They'd have to do the whole thing again and start from scratch, because the settings that they used in the winter and the summer would be completely different because they weren't controlling the environment around the printer. So check your user manual for requirements, but printers generally like to be the same temperature and the same environment that we're in. Another good example of that is I was doing some training in Samoa with some customers up there, and they'd bought a digital printer, and they'd bought one off Trade Me here in New Zealand. They'd imported it themselves, and they'd tried to set it up and run it. Because they had no understanding of what they were doing, they'd never run a digital printer before. And they, as far as they were concerned, is how hard is it? How more difficult is it from running a computer printer? Something that prints A4 paper. So they had it sitting in a garage, and Samoa in a garage during the day was 30-something degrees, 35 degrees, and they dried all the ink in the heads. And then they had to get a service technician out from New Zealand to service it. They ended up replacing all the heads, and it probably cost them more than if they had bought a brand new printer and had the service technician come to install it. So they learned a very valuable lesson regarding controlling the environment. Once they'd had the technician up to service the printer, and he was absolutely shocked at the conditions it was in, they put it into the office, which they could have done in the first place if they'd realized, and all their problems went away. So print room environment is very, very important. So print room, they like to be air conditioned, flat level floor, hard, clean, dry, and dust-free with no direct sunlight. Okay, air conditioned, 20 degrees, we talked about that. The other thing I need to say about air conditioning is so many of you will have an air conditioner for your printer, but you'll turn it off when you go home, and then you'll come in the morning and it's cold, so you'll crank it up to 30 degrees to try and warm up the environment. If your air-conditioned room is insulated to some extent, you're actually better to leave the air conditioner on. It will cost you less in the long run to leave your air conditioner running, generally 24 hours a day, 7 days a week, 365 days a year. If your room is insulated, then your air conditioning costs will be lower than if you turn it off every night. Sounds bizarre, but it's true. Running an air conditioner, just ticking on and off, doesn't take much energy. Running your air conditioner to run it up to a nice warm temperature and then it gets cold overnight will cost you more money. So to leave your air conditioner on will actually cost you less money. The next one is the flat level floor and the hard floor surface. Flat level is obvious, but the hard floor surface. How many of you are running your printer on carpet? If you are, take it out immediately and paint the floor or put lino down. I've heard people say, oh yeah, we put it on carpet because that way we don't get the dust. Well, actually you're making it worse. You're not making it better. A lot of dust will get trapped in the carpet and it will get kicked up every time you walk past. So you will be getting a lot more dust in your prints if your printer is sitting on carpet. And that last one, no direct sunlight. You can see from this picture, this was a photograph I took from a company in Brisbane actually. That there is a column of the overhang. The upper floor of this building goes right out. So at no time of the day is this in direct sunlight. So pretty much what we've got here is we're looking at shaded all year. It's never going to get indirect sunlight. And you can see here there's a brick wall outside and some ferns, but you see what I mean. It's not indirect sunlight. Okay, so the printer operation. Load the media so the print surface is not contaminated. This is a Roland printer. A lot of these photographs are of Roland's because that's what I've got. That's what my colleague Chris in Australia is running as well. This is what we call a core plug. It goes into each end of the core and it sits on these two rollers. So when the media is fed through, the only thing touching those rollers is the core plug. So this will lower the friction and allow it to pull through much more easily. And if you run it without the core plugs like that, you've got all of this being contaminated by these rolls. Any dust on these will be transferred to your media and the friction is much higher. I know those of you running other types of printers like the HP latex printers, they handle the roll quite differently. There's a mandrel through there and this core plug doesn't sit on rollers. It actually mounts into an unwind device. That's even better because there's nothing touching the surface. But just bear in mind, if this is the sort of system you're running, don't run it without the core plugs. Ensure the media is loaded straight to avoid skewing and possible head crashes. You can see here my colleague Chris is pulling the media out. He's pulling it in the middle. As he pulls it, he'll just give it a bit of a wiggle side to side as he pulls it down. That'll just pull it straight as it comes through. That just generally makes it easier to load it. I know these days a lot of the modern printers are self-loading, so you'll push a button and it will wind it through and it will load it correctly itself. And usually it will load. For vinyls, it will load quite happily. I know some of you that are running heavier duty materials like reflectives or banner, it may struggle to wind it through properly, but essentially you've got to get it loaded correctly or loaded straight. Now, if you are running it onto a take-up roller and Chris is taking it down around this roller and sticking it onto this core here in the bottom, I recommend just one piece of tape in the middle. I know a number of people use 3 or 2. The trouble with using 2 or 3 is that if you put one on each end, if you get this one 1 millimeter or 2 out from that side, this roll will not wind up correctly. It will end up telescoping as it winds up. So we recommend only using one bit of tape to hold it in the middle. Some people will cut this at an angle so that you've got an envelope shaped piece on the front here, like a triangular piece that will help it roll up around here more easily. Otherwise, what I tend to do is I'll just keep an eye on it as it's printing and make sure that the ends do wrap around there correctly and they don't catch, and then it will wind up correctly. By having 2 or 3 bits of tape on there, you're generally asking for trouble. You won't get even tension on the take-up roll. Brings me on to some calibrations. There are 3 calibrations that you'll find on almost all the printers. That's a nozzle check, that checks to make sure that all the nozzles are firing. The feed calibration, that works out how far forward it moves every pass. And the bidirectional calibration, that works out where to put the ink when it's printing in 2 directions. So I'll talk about each of those in turn. The first one's the nozzle check. What we've got here is the yellow ones here, you can't see it, but this is a nozzle check from my Roland, and you can see here that nozzle didn't fire, so it's blocked. This nozzle did fire, but it's deflected. You can actually see the nozzle is actually pushed up slightly. And in some cases, you don't see it on this one. There's another deflecting nozzle there. Sometimes you'll see the stream of ink isn't in line with the row above. It will be deflected to the left or to the right. So what's happening here with a blocked nozzle is that the ink has actually physically blocked the port of the head. So no ink's coming out. Doesn't matter how much you fire it, it's not coming out. Running a cleaning cycle and forcing ink through the heads or sucking ink through the heads will help to clean it. So you can clear blocked nozzles with a good cleaning cycle. Now, deflecting nozzles are slightly different. That essentially is where you've got the round orifice of the nozzle and you've got a bit of crud built up, a bit of ink dried on part of that nozzle. So when the ink comes out, it comes out at an angle because that dried ink is getting in the way. That's causing the deflecting nozzle, and it's either deflecting up or down or left or right. There's no left or rights on here, but you see what I mean. So I would recommend that you did a nozzle check every morning. So when you come in the morning and you start up your printer, just run a nozzle check. It only takes a few seconds and it will soon tell you whether all the heads are firing correctly. And if they're not, then do a quick clean and see if you can get all those heads working. So doing that every day will give you a good idea of how your printer is going to perform. And I'd recommend this daily. If you're struggling to see the yellow test print, use a blue or UV light. I ended up picking up a UV light from JCar. I actually made a mistake. I thought I was picking up a normal torch and I ended up with a UV torch. And in hindsight, it was actually a good thing I did, because shine that onto your test print and it will show up the yellow. So if you're having trouble seeing the yellow heads, a blue or UV torch will help you. The next type of calibration is called a media or media feed calibration. This is going to be quite hard to see, but I'm hoping you can see some banding or some marks here in the print. That's essentially caused by the media not feeding forward correctly. What tends to happen is that the media feed calibration is the calibration that works out how much media to move forward for every pass. So if you've got it incorrectly calibrated and it's not feeding enough forward, you'll get a dark band like this. If it's feeding too much forward, it will cause you to have a light mark between the passes. So you'll end up with a light mark in there. So usually if you're seeing media banding, either light or dark bands, usually the cause is the feed calibration, and you need to go and check the feed calibration. The other thing I need to stress here is that every printer may call this something else. So it may not be called a media feed calibration. I don't know what your printer calls it, but there are a number of names for this. So if you know what it is, you can go and check it. And that's what it looks like on a Roland. A Roland will print something like this. It will print a whole lot of marks like this, and it will have a little arrow up under one of them where the printer is set. So if there's a gap and the arrow is here beneath this, then I would go and say, well, okay, then it's not that one, and I'll recorrect the printer to say, well, this is the correct one. So you can see here, this is the gap or this is the overlap. So choose the one where it correctly aligns these two blocks together with no overlap or no gap, and make sure that the printer is set to that. There may be numbers under here, and you can set in your printer the correct number so that you can correctly set it. That would be how I would go about setting the media feed calibration. Now the next one is the bidirectional calibration. This allows for differences in the release of the ink drop when you're printing in both directions. I would say 99.9% of you, of the 60 odd people that are on this call, I guarantee you 58 of you will be printing bidirectionally. It's quicker. That's why everyone does it. Bidirectional printing means that every time the head moves across, it prints, and then it prints again on the way back. Unidirectional printing prints out and then goes back without printing, prints out and then goes back without printing. It only prints in one direction. Unidirectional printing will give you a better, more consistent looking print, but it takes twice as long to do it. And no manager is ever going to sit still while the printer's running at half speed. Everybody wants it to run at full speed. So that's why I was saying pretty much everyone on this call will be running bidirectional. Bidirectional, the issues with bidirectional with the quality of the print is that to print this drop there, it needs to know exactly when it's dropping that. So it'll drop it here and it will fly through the air and land on that spot because of the speed of the head in this direction. So to get another drop of ink pretty much in the same target point traveling backwards, this distance needs to be the same but in the other direction. So the bidirectional calibration calibrates the time between dropping the ink and the target for both directions. Now, interestingly enough, this is definitely called different things in different printers. I was working with a large format Durst printer for the road sign side of things, because in Australia, we've got a number of Durst printers printing traffic signs. And Durst doesn't call this bidirectional calibration. Durst calls this the drop fly time. Who would have thought? Strictly correct. It's the amount of time that the drop flies between there and there. So it is officially the drop fly time. That's what Durst call it. Roland call it a bidirectional calibration. Mamaki may call it something else. HP may call it something different again. But essentially, all it's doing is just allowing for the differences in drop release when printing in both directions. I was doing some work in Germany a number of years ago with one of my 3M colleagues, and we were playing with a big format printer. And I was saying, well, how much difference does it make when you change that? And he was saying, I don't know, I've never tried, let's have a go. So we set this thing out to the maximum that we could. And if we were printing something that looked like my hand, and normally the bidirectional calibration would get one lying right on top of the other. In this case, you might as well have had two hands offset by about 50 millimeters. That's how far out we could get the bidirectional calibration. It looked like two distinct images printed side by side. That's the difference that bidirectional calibration can make. So check that your bidirectional calibration is working correctly so that you're actually got that ink drop release in both directions. And the Roland one, I don't have a picture of it, but the Roland one is a series of bars that need to line up with each other, which seems obvious. Some other settings that you'll have in your printer, the head height. The head height must be correct to get correct, accurate dot placement and to avoid the head strike. We'll talk more about head strikes later. I've got some pictures. Essentially what we're saying there is the higher the head height, the more accurate your bidirectional calibration needs to be. But the higher the head height, the more chances of everything going wrong. Any airflow can blow the ink off course. So usually what I would say is lower the head height to as low as you can get it without causing a head strike. So you want a low setting. You want that print head to be as close as you can to the surface without it touching. The higher you go, the more variables come into play and the harder it is to print. Heaters. I get a lot of people saying, oh, how hot should I run my heaters? Well, I don't know. Well, what do you mean? You've been doing this forever. Why can't you tell me how hot my heaters need to be? Because it depends on you. It depends on your printer, your print environment, your room, your everything. So I can't tell you how hot your heaters need to be. It's going to be a matter of trial and error to see what works for you. But most printers have got several different heaters doing different tasks. A lot of them will have a preheat, so they'll warm the media up before it gets to the print head. There'll be a heater under the head, and there'll be a heater on the outfeed as well. So it's the same for whether you're using a solvent, a latex, or even a UV printer. They will all have heaters in there to warm the media up, because the print will print better at a certain temperature. Yeah, as I was saying before, solvent printers could be 50, 60 degrees, but latex printers could be over 100. So I can't tell you how hot to have them, but having the correct heat setting is critical for good print quality. Now, a print dryer, they're not so common these days, but back in the days of the old smelly solvents, sometimes you'd get a print dryer, and a print dryer was usually a blower or a heated air, heated air driven blower that would blow hot air just before it rewound the media. So that would often be quite down low, down close to the floor. I know Mamakis were very good at having those, so that as you wound the film up, it gave it a bit of extra drying to drive off some of those solvents. Because if you didn't, then you could end up with the solvent still damp in the roll and the layers sticking together on the roll. Not so common these days, but you can still see them. The next one is the platen vacuum. The platen is that area under the head with all the little holes in it. Essentially what that's doing is that will suck a vacuum through those holes to try and suck the media down flat. So when the printer is printing, you're not getting any variations in the print height. So the platen vacuum is the amount of vacuum that's sucked down to hold that media flat. If you set that platen vacuum too high, you can get media feed problems because it's sucking down so hard it's having trouble pulling the media through. So usually what I say with the platen vacuum is set it to automatic and leave it. Don't fiddle with it unless you have to. Usually when you're fiddling with it, it's because you're running something like a mesh banner and you need a much higher vacuum because most of the air is sucking through the mesh and it won't suck flat very easily. So often if you're running mesh, you've turned up the platen vacuum. I've had a number of people nod and laugh when I say how many people have printed mesh and then gone back to printing normal vinyl, forgotten to change the platen vacuum and then wondered why they were having problems. And you get all these people knowing, yeah, we've been there, we've done that. So what I generally say is leave it on auto unless you need to change it. There are a number of other settings in there as well, but those are the general ones that are important. Now, print curing. Curing is not something that you just need to do for solvent printers. It is critical for solvent printers, but it's also quite important for UV and latex because they are curing fully on the printer. You need to make sure that you've got a correct print mode so that your UV print or your latex print is also cured. So usually what you've got is print curing for a solvent print is generally going to start on the printer but complete off the printer. You have to leave the print to cure before you use it. So run it off your printer and hang it up or leave it loosely coiled before for a period of time before you use it. Now, UV curable, sometimes if you're not running, if your lamps are getting old or you're not running quite enough energy into those UV lamps, the media can come out slightly sticky. If it comes off slightly sticky off a UV printer, then you've got a problem. You need to look at your UV lamps to see if you can increase the power to the lamp. If you can't increase the power to the lamp, it's time for a new lamp. They are replaceable, and usually it's a service item that you could do yourself. You may not have to get a service technician in to do it. Now, a latex printer should also fully cure on the printer. If it doesn't, some of the things that you'll see is if you didn't cure it right, the latex ink will still be wet as it comes off the printer. And obviously that's a problem. You'll need to check your heat settings to make sure that you heat it up a bit more. So you either want to run more heat into it or slow it down to make sure that that latex print cures. One of the other latex issues that we sometimes see is that people will say it comes dry off the printer and then gets sticky about 10 or 15 minutes later. That means that it's not fully cured. You need to, once again, increase the heat or slow the printer down. What's happening where it's getting sticky afterwards is that you've done enough curing for it to be dry on the surface, but there's still moisture inside that comes up through the surface of that ink 10 or 15 minutes later, making it sticky. A number of people have said, can I fix that? The simple answer is no. You have to go back and reprint it and cure it on the printer. You cannot get a latex print to cure if it's not on the printer. I've had some people say, well, can't I run a heat gun over it? Well, you can, but you're more likely to bubble the print than you are to dry it. So these two, you've got to watch the curing on the printer. Solvent printers, it will cure off the printer. Uncured prints will retain solvent that will affect the behavior of the film. You'll get poor film adhesion. You'll get edge lifting and curling. You'll get the film will be too stretchy. It'll be too sticky, so it'll just grab onto everything. The image will be really soft and easily scratched. If you run your fingernail over it, that's a good test. So if you run your fingernail over it, if the image is dry, your fingernail will just slide across the surface. If it's still got solvent in there, your fingernail will chatter across the surface. And the other thing, you must not laminate or apply the print until it's fully cured. If you laminate a print straight off the printer, all you're doing is you're slowing that curing down to a crawl. What may have taken 12 to 24 hours or 48 hours to cure may take a week to cure if you've laminated it. By adding that layer on the top, you're just trapping that solvent in there. I've seen some that have been laminated and then applied, and then they wondered why they had bubbles the size of, cricket balls, massive great bubbles in the print. And that's because the solvent that they'd trapped under the overlaminate had soaked through everything and had bubbled the entire thing off the surface. So it's really, really important with solvent films that you cure them correctly. And what we'd recommend you do is to hang them vertically for fastest curing. This is Chris in Australia hanging them over his pin rack to dry. In my lab, I've got these stainless steel wires and little pegs, and I'll hang up these prints to cure. So I'll leave them hanging until they're dried. Now, the other way that people do it, this is not ideal, but it is quite commonly done. And I know a number of you may have been using this method already. If you're using this method, you have to make sure that you, if you're leaving them unrolled, don't leave them standing just on the floor, because the solvent is heavier than air and will sink to the bottom. So you've got this thing loosely coiled and you've got it standing on the floor. Why bother? The solvent's trapped in here and it's not getting out. You've got to get them off the floor. Get a rack or something underneath them. I've seen some people put a computer fan or something underneath it as well. That's great. Make sure that your computer fan is sucking down, so your airflow wants to be down and out. If you put a computer fan or a fan of some description in there blowing up, you're probably defeating the purpose of the exercise as well, because blowing up, that heavy solvent, unless you're blowing hard enough, that heavy solvent won't be pushed out the top. It'll just be circulating inside here. The other thing is, if you don't loosely coil this and you've got any layers that are touching, you won't be getting curing. So your ink will not cure if the two layers are touching each other. It's like putting an over laminate on it. So you've just got to make sure that they are correctly loosely rolled. Your curing time will be longer with a loosely coiled. It will be quicker if you've hung it up to dry. I've got some people that say, oh, we just run it out on the bench overnight. Yep, that's good, that works. But bear in mind, it's not as good as if you'd hung it up. You've still got to get that ink to run itself off. So the next question is, how long is it going to take to cure? That time will vary. For IJ180 and a solvent printer, you may be looking at 24 to 48 hours. I know some of the Mamakis, the curing time was a bit longer with some of their inks. Some of the Rolands was a bit shorter, but the Mamakis had an absolutely bulletproof print by the time it was cured. So I'm not saying one was better than the other because it dried more quickly. I'm just saying that the Mamaki, a bit slower drying, gave you a very durable print. The Roland cured a bit more quickly, but maybe the ink wasn't quite as durable. So the time for curing will vary on the temperature, whether you hung it up or you loosely rolled it, whether you had any airflow through it, what type of ink it was, so the type of printer and ink, and how dense was your image, how much ink did you lay down. If you lay down very, very high ink densities, then it's going to take longer to cure. So those very, very dark colors with lots of ink, it'll take longer. What you've got to do is you've got to test your own process to determine the curing time. And 24, 48 hours, I don't know. That's going to depend on your process. Smell it, scratch it, or stretch it. That will soon tell you whether it's cured.
Michael?
Yep.
Might be a good time to mention our IJ280, 1/3 the curing time compared to other films.
This is what I've got here on this side of the page.
Oh, sorry.
Something that's just been added in. The new IJ280 has got a solvent-resistant layer in it. This is an absolute godsend for those running solvent printers. So we've got a layer between the vinyl and the adhesive to protect the adhesive from the solvent. So when you digitally print it, the solvent won't make it into the adhesive. Part of the problem with the print curing is when you've got that really tackiness and that loss of that slidability, that's because the adhesive has been swollen by the solvent. The 280's got this solvent resistant layer, which means it's going to dry more quickly. So what we've done is we've protected the adhesive from the solvent, and it will dry more quickly. So a 24-hour dry time may be as low as 8 hours. We've had some customers say that they can print in the morning and it's dry enough later in the afternoon to laminate it. So they may get a 24-hour dry time as low as 8 hours by using 280 with that solvent-resistant layer. So there's a massive benefit for using 280 if you're using a solvent printer. Okay, changing gears, the printer and RIP operation. RIP stands for Raster Image Processor. This is a complete change of gear. We're now looking at the printer software side of things rather than the printer itself. The RIP will convert the native artwork into dot placement information for the printer. So essentially what it's doing is it's taking the original color file and it's splitting it into a separate file for each color. So if you've got a 4-color printer, it will separate it into a file for cyan, a file for magenta, a file for yellow, and a separate file for black. So what you've got is the RIP will start off with one image, say for example, just for argument's sake, it's 1 meg. You've got a 4-color machine, it's going to rip it into 4 separate colors. So you've now also got 1 meg of cyan, 1 meg of magenta, 1 meg of yellow, 1 meg of black. So your original file will become 5 times the original size. So the original file and 4 times that. So immediately your RIP operation is going to be using a fair amount of computer grunt. So it's quite important for the RIP that you actually use a machine that's fast enough to do it. Now, what I've found is that traditionally with the machine that's doing the ripping is that it tends to be the slowest or oldest printer in the place, because what's happened is that the machine that you're doing all your graphics work on has got a bit old and tired. So you've retired that machine and you've got a new machine to do that. So what do you do with a retired machine? Oh, I know, it can do the RIP for us. So you're actually bottlenecking your operation. The RIP machine should be the fastest machine in your office, only because that's what's standing between you and the production. So you'll send something to the RIP and it could be minutes, many minutes in some cases, to rip that before it prints it. That's slowing your printer down. It's quite important to make that machine one of the fastest that you've got. So it needs to be fast, it needs to have a lot of internal memory to manipulate the files, and it needs to have a lot of storage space for all of the files that you're dealing with. So it is really important that your RIP machine is a really high-end machine. It should be the fastest machine that you own. It should be the fastest computer in your organization. Very seldom is it, but it should be, because that's the one that's standing between you and the printer actually starting and working. So getting the best from your RIP, I'm not a RIP expert. There are a whole bunch out there and I've used a few over the years, but attend a RIP training. So you need to get training on the software from the software provider. And that's really important. And I know the computer letter guys now have got people that specialize in this sort of thing, and they can get you RIP training if you need it for the RIP that you're using. So this particular training session, we're not covering the actual operation of the RIP because there are just too many of them. Brings me on to media profiles. I've done courses where I've had people come along and they've said, well, what's a media profile? That's okay. I've been there, done that. The media profile is essentially information that gives the RIP and the printer on how best to print. So basically it's set for a specific combination of RIP software, print media, ink, end use of the graphic, environmental conditions, and ultimately the printer. So that profile is specific to your printer and your printing operation. So while you can get generic profiles, and we'll talk more about that shortly, you may find that a custom written profile is what you actually need to get the best out of your printer. So the profile, well, what is it? The best analogy would be baking biscuits or baking cookies. If you don't have a recipe, how the hell can you be expected to get a decent looking, decent looking cake or biscuits? So if you've got flour, sugar, eggs, baking powder, chocolate chips, cocoa, and you want to make biscuits, how do you know, without the recipe, how do you know what order to add the ingredients, how much of each ingredient to add, how to mix it, what sort of dough, what's it supposed to come out like, how hot is the oven and how long do you put it in? All of that's the recipe. That essentially is the profile. The profile does all of that. So it takes the ingredients, the incoming image, sets everything up correctly and puts it into the oven, the printer, to give you the output, the cookies. So essentially, if you change the recipe, like setting the oven to a different temperature, the resulting biscuits will be different. It's the same as the profile. If you change something in the profile, you can get a different type of print. It's quite important to how your image looks, setting the correct profile. It is a subjective process, and the profile does reflect the preferences of the creator. What I mean by that is that whoever created that profile is, that they're deciding what might look best for them. Good example of that is I had a custom profile written for our Clearview film, so our clear vinyl that we use for, it's optically clear that we can print onto. I got a custom profile written for that. And when I used it, I looked at the output from that and thought, I don't like that very much. And then I looked at the standard IJ180 profile that I was using before that, and I said, oh, that actually looks better. And the reason for that, despite having a custom profile written, I found that the generic profile was a better fit for my media. And that was because whoever wrote that profile, they thought the output for that profile looked better. I didn't. It's subjective. Whoever wrote the profile, it's their preference. So you may not get a profile that suits you, but have a look around. There are quite a few profiles that are very similar and will give you some good results. As I say, similar materials often have very similar profiles. For example, our IJ280 film, we've had very few profiles for that new media. I believe, what's today? Today is the 1st of September. The rest of the world is releasing that product today or next week. So now on our, if you go and look in the 3M website, we will have profiles for 280 and then now they've been released. So we may not have had many profiles in the past, but what we found, and most of the people here in New Zealand, because we've been using 280 for 3 months, what we found already is that the generic profile or the 180 profile worked just fine. But don't be afraid to experiment. You might be surprised by the results. I've been in and I've mucked around with profiles quite a bit over the years, and I've found some really amazing looking results just by changing to a profile that I never expected would have done a good job. And who would have known until you'd had an experiment and tried it. So even if you don't have the exact profile, have a look around and try and find something similar. As I say, a cast profile for a cast media, which whatever the media type might work fine. Generic profiles. Roland have got a bunch of generic profiles. I use the generic profiles in my Roland purely because I know that IJ180MC, the generic profile, prints really well on my IJ180. Why is that? Well, interestingly enough, the generic profile that Roland wrote, they were using IJ180C. So they were using my film. So that's why the generic profile works so well on the Roland. So the generic profile might be fine, but have a muck around. You might be surprised by what you get. The other thing there, apart from the media profiles, most of your RIP software will have a whole bunch of other settings in there. Have a play with some of those settings. You might find some unusual things. I know my Roland has got a setting there called print and display, or sorry, sign and display. If I go to the sign and display setting, what it does is it just dumps more color in. So it will make smaller numbers of colors really stand out from the surroundings, and it will make the media really, really look good. So it'll make whatever you're printing come out really well. However, that on my particular printer, I don't use it because in the white, it chucks in a little bit of magenta. So all of my whites come out faintly pink. And that's just because it's just pushed the colors slightly too hard for that particular printer. So I don't use that setting because it makes them pink, but it does make the rest of the colors pop. So don't be afraid to experiment. You might be surprised. Now, one separate slide here. This one's just a bit different, and we just need to be aware of this. You can get color variation across the width of the printer. Like, it's not very common, but you can get it. I've heard some people say, oh yeah, my printer does that, and it's always worse on the orange, or it's always worse on the green, or it's always worse, whatever the color is. And you can get variations. So from one side of the printer to the other, a minor color variation. So if you're doing multi-panels and you print them one after another out of the printer, you will get mismatched edges coming together. So the left side of the print and the right side of the print will be placed together, and any color variations will be noticeable. So what we recommend is a thing called topping and tailing, where we print every other image upside down. So in this case, edges, the top edge of 1 and 2 come together here, and the bottom edge of 2 and 3 come together. So this is called topping and tailing. Every other print is printed upside down. So you print one way and print one the other, head to toe, topping and tailing. That will avoid noticeable color changes. The only time you cannot do this is if you're printing a metallic, and we do have a metallic silver in our digital range. Do not top and tail a metallic. Metallics have got a metal flake in them that gives them that metallic look, and that metallic flake, unfortunately, will orient itself, and if you flip one over, it will change the look. And I've seen that where we had the whole side of a truck and one image got rotated when it got put on, and it looked like something out of a completely different batch. So don't rotate a metallic. But apart from that, this is a good rule of thumb for other digital prints. Right, on to color management, and time-wise, I'm exactly where I should be, so we're looking good. Color management. You need to ensure the color output from your printer is correct. And you'll get problems with color management because there are so many ways to describe or define color, a whole bunch of different ways to create the color. The perception of the color will all be affected by the environment that it's in, and different devices will produce a different range of color. So to describe that, firstly, color systems, RGB, used in cameras, scanners, monitors. It's got a very good color range, and it's what we call an additive color. So if you add red, green, and blue together, you should get white because they're additive. So those three colors added together will give you white. Now, if you add red and green, you get yellow. Now, if you add green and blue, you get cyan. And if you add blue and red, you get magenta. So suddenly you can see CMY. So you've got your cyan, your magenta, and your yellow. Now, this is called a subtractive color. Tend to be used for output devices like printers. So you'll print cyan, magenta, and yellow. And if you print the three together, you're supposed to get black. Do we get black? No, we get a lovely muddy brown. That's because the colors are not perfect. And in a printer, despite having good pigments, we will never get perfect pigment. So you can never get a pure black out of cyan, magenta, and yellow. So where we add in black, we call it K. It's not B for black because it was B for blue. It's K for key because it's a key color. I don't know, but black is K. Black, it's not from another language, but they call black K. So we add in the black channel to make this pure, because you cannot get a pure black by adding cyan, magenta, and yellow together. So the color range is smaller than RGB. It is a subtractive color. So when you add these colors together, they will head towards black, not white. And it's tend to be used for output devices like printers. That brings me on to color perception. I don't have it, and if someone can find it and send it to me, you remember that that Facebook or internet thing that went around a few years ago, is the dress gold or is it blue? And some people said it's blue and some people said it's gold. It all depends on your color perception. Some people saw it as one color and some people saw it as another. This is an example of that. Now, if you look at this, you'll look at this and you'll see these two shades of blue to be different. People tend to see this one as being lighter because of the white each side. They tend to see this one as being darker because of the black each side. It is a color perception thing. These colors are identical. There was another one I saw and I wish I had a copy of it, but I don't. It was a beach deck chair, like one of those ones that sit in the sand, right down low to the sand. And it was two shades of gray on the back and the seat. And because of the way the sun shone on it, they looked like different shades of gray. But if you covered up everything else and just exposed a spot on the seat and a spot on the back, you could tell the two shades of gray were identical. But because of everything else around it, you would have sworn that the two shades of gray were quite different. One was a light gray, one was a dark gray. but essentially color perception. So we can change colors or change our perception of the colors depending on what's going on around it. Another form of that is what we call cast. This is where if you look at an image, you can alter in your brain how you actually see the image. You can see this woman here is quite cyan on this side of her face, yet quite yellow on this side of her face, either side of the dot, the cross. Now, what I want you to do is to stare at this dot for probably 20 or 30 seconds, and then move your eyes to this dot. And you'll immediately see that your brain has started to subtract the cyan from one side and the yellow from the other. So when you look at that, you'll notice that she suddenly appears to look correct because your brain has subtracted those colors. So I'll just give you a minute or two to do that. And I've done this in training courses with people, and you go, oh, wow, yeah, I can really see that, hey, it's amazing. She's actually changed to be a normal color. Neither of these two colors are correct. One's too cyan and one's too yellow, but she looks correct if you spend time looking at the other picture first. So I'm assuming you've all had have a chance to look at that and see how the color of her face changes depending on what your brain has subtracted. So that brings me on to leads in nicely to lighting and color. Different light sources will produce different colored light. So the old incandescent bulb that grandma may still have at her house, I know I don't think I've got any left in this place at all. Incandescent lights give a very yellow to orange color. So you can see here in this light box, this is an incandescent bulb. Fluorescence will give you quite a green look. LEDs can give you anything you like because they can be programmed up to give you pretty much anything you like, but a cool white LED will give you a very bluish white, yet a warm white LED will give you more of an orange yellow, possibly even as far as an incandescent. So a number of people like warm white LEDs in their houses because it reminds them back of the colors you got from the incandescent days. Personally, I prefer cool white. That's just me. My personal preference is for a cool white, but that's just me. But what I'm really saying here is that whatever you've got to check your color under the appropriate light source. So what I mean by that is if you're doing a graphic on a car that's going to be outside, because cars are outside, don't check the colors for the job that you're about to print. Don't check them inside in your print room under fluorescent light and expect the color to be correct. Go outside and look at them in daylight, or have some method of simulating daylight. Like this light box can simulate daylight. That's the daylight. That one is a fluorescent and that one is an incandescent. So check it under the appropriate light source. If you've got graphics that are going inside and they're going into an office where it's all fluorescent lights, then you want to check under fluorescent lighting. Maybe you want to check it under LED lighting. What sort of lights have they got? Find out what sort of lights are there. Is it a warm white LED or a cool white LED? It will make quite a difference to how the color is perceived by the customer. You may need to alter the colors in your images before you print them to get it to print correctly. Which brings me on to a thing called metamerism. Unfortunately, I can't show you metamerism. That's something that we can only do in person. But metamerism is where you can get two colors that look similar under one light source can look quite different under another. So essentially, I've got samples that, like of a russet brown color that there are 3 different colors and 2 of them look the same, and then you put them under another light source and another 2 look the same. So 1 and 3 may look similar, and then 1 and 2 may look similar, or 3 and 2 may, variations. Under different light sources, you can get colors that will look different. So that's why it's important to match the color under the light that they'll be viewed. So swatches, check them indoors or outdoors, wherever you're actually dealing with it. Okay. What we've got now is describing color. So rather than RGB or CMYK, we actually do have ways of describing the color. Commonly, we'll use a system called LAB or YXY. This is called the CIE 1931 diagram, and this is a very common way of describing color. So essentially, every color that you can see will be somewhere in this box, but the lightness of the color will stretch in and out of the page. So from 0, with the capital Y being 0 would be black, the capital Y of 1 would be pure white. So from the intensity, which is the capital Y, so that's coming in and out of the page, or the color. So X and Y is what X and Y, and the capital Y is the intensity of the color. And they designed that back in 1931, and CIE is an international organization for color. They did another job of that in 1976, which had a better shape image than this, but no one ever used it. They still use the 1931 diagram. Now, a more modern version of that is LAB, where your A and your B are measured on these axes. So from red to green, and from blue to yellow, and all of the variations around that. So your A and your B are your colors measured in these directions, and your L is the lightness. In this stage, from 0 is black to 100 being white. So that's measured more like a percentage. So just different ways of measuring the color. And there are, on the internet, you can easily find calculators that will calculate, that will show you, if you're given, someone gives you a color in YXY, you can get that same thing converted to RGB or CMYK or LAB. There are converters out there that will convert the colors for you. Now, the color gamut. The color gamut, a gamut is a range of colors. So the color gamut is the range of colors. So the visible color gamut would be everything inside this circle. So in this case, it's every single color in the world that the human eye can see will be inside this box or inside this circle. Now, we've got visible colors that you simply cannot reproduce. The next one down is RGB. This yellow box here is RGB. Now, what we're saying with RGB is that this is the one that we can take a photograph of and we can display on our monitor. So we can show it on a monitor or we can capture it with a camera, but we can't print it. So we've got colors that we can see, but we can't reproduce on the screen. Good example of that are fluorescence. You can see fluorescent colors, but you cannot reproduce them on the screen and you can't print them on a printer. Fluorescents are well outside the RGB range. Now, if you get a bit smaller, the next one down is Pantone. Now this here is the Pantone one. You see we're getting smaller and smaller and smaller. Pantone's a bit different. Pantone is not a color gamut per se. It's actually a set of spot colors. So if you guys have seen Pantone color books, and I've got one right here. So you guys have all got Pantone color books like this. That is a set of Pantone colors. There's a whole bunch of colors there, but they're not between colors. In the color Pantone book, there is not a color. So what we're saying is this is a set of spot colors. So you might get a color here and a color next to it, but there's nothing actually in between. So if you think of this like a set of holes, there'll be holes where each color is, but there are gaps between the holes where there isn't a color. So Pantone is not a graduated range of colors. It's a set of individual spot colors. So most customers will pick a Pantone color, and that's okay, because if we've got a Pantone color, usually we can reproduce it. Now CMYK, this is this little one in here. Someone see the issue? We've got this one here, CMYK. That's what we can print. That's what your print is capable of doing. But here's RGB. Here's what we can print on the screen. The color gamut of CMYK is very small. So we've got colors that you can see on the screen, but you can't print. Or we've got Pantone colors that the customer can specify, but we can't print. So we've got a problem. When we come to reproduce or come to make the images for the customer, we may have a problem that we call out of gamut. And out of gamut means that we can see it or the customer specified it, but we can't print it. And the question is, What do we do with out-of-gamut colors? What we're doing here is a thing called a rendering intent. The rendering intent is what the RIP software is doing to deal with the differences. It can ignore it or it can change it. So the strategy used is called the rendering intent. So different rendering intents will suit different situations or file types. And what I mean by that is that we've got to have a way of dealing with that difference. We've got to have a way of finding a solution to this issue. And the essential way is we either ignore the problem and print something else close, or we change the color and print something. So how we do that's called the rendering intent, which brings me onto this slide. Colorimetric rendering. Colorimetric rendering essentially attempts to preserve the colors that are in gamut, and it's best for files with limited colors or PMS colors. So what we're saying here is if you've got a 4-color file, or a customer's logo, it's only a small number of colors. It's not a photographic image. It's purely just a limited number of colors. You're better off doing colorimetric rendering. Photoshop will do this automatically. Photoshop is very, very good at figuring this out itself and doing it. So if you take an RGB image and convert it to CMYK in Photoshop, it will look at that immediately and decide what type of rendering it needs to do depending on the number of colors in the file. So Photoshop does this itself. It does it in the background and it's very clever about it. Your RIP software can do this as well. Where it does it and what it calls it and how it does it depends on your RIP software, but it is in there somewhere. So colorimetric rendering, what it's doing is, if we look here and we say, here's our RGB image and we've got 2 colors, A and B. So we've got to print CMYK, so our target is CMYK. This one, A, is out of gamut. We can't print it. We cannot get that color. It's just not available to us. Yet B, we can get. It's in, sweet, no problem. So colorimetric rendering, the way it works is that it looks at B and says, it's in, let's just leave it alone. Let's not fiddle with it. But A is out. I need to get A in. So what it does is it will move A towards the white point. So it will move it towards the center, and it will move it enough just to get it over the border into where it can print it. So it will replace the value of A with another value of A that it can print. So it's changed A, but it hasn't changed B. Now that's important to realize. So it's only changed the one that was out of gamut. With a small number of colors, you won't notice that one got changed and the others didn't. That's why this is best with limited colors. Now, the second type of rendering is called perceptual rendering. Essentially what it does is it attempts to preserve the range of colors in the file. So this one's best with large numbers of colors, photographic images in this case. Same situation, we've got 2 colors, A and B. A is out, B is in. It's got to move A just the way it did before to get it in. But this time, instead of leaving B behind and not touching it, it's moved B in relation to A. So it's moved it the same amount or a relative amount towards the white point. So it moves every color. The reason for it moving these colors, and you think, well, why the heck did it move B? It didn't need to move B. What it's done is it's retained the relative difference between A and B. So it's kept these relative to each other. In the first one, it moved this one, but not that one. By changing both of these together, it effectively stops some colors looking a bit odd when they're next to another. So for example, if you've got a picture of a face and you do a colorimetric rendering on it, you can get steps in the graduation. So you'll get lines in the face where it's changed the color. You can get strange looking colors like where something should be yellow, but it's come out more gray because of the way it moved one color and not the others. So you can get a face taking on a different hue, or you can get steps and graduations. So perceptual rendering will not do that because it's moved everything. you can't get the steps and you won't get those strange looking colors. Don't bother doing this with just a couple of colors. It's not necessary. So perceptual rendering is what we'd do with a photographic image, and there are reasons why we'd do that, and that's to keep the graduations and the steps looking good. Different RIP software may use different rendering intents within one file. I've seen some RIP software that has taken an image, and Photoshop does this very well. It's taken an image and it said, okay, I've got a big block color in the background and then I've got a photograph in the middle. So it will look at the block color and use colorimetric rendering on that, and it's taken the photograph and done perceptual rendering on that within the same image. It's looked at the image and dealt with different parts of the image with different rendering intents. Some of the software is pretty smart these days. Okay, so that brings us on to implementing the color management. True management controls the entire process from the image creation up here when someone's taken the photograph right through to the output going to the customer. How much of that do you control? Probably only that bit. More often than not, someone's brought you their artwork and said, print this. That's all you've got to control. So your out of gamut is a problem because you've had no control over this part of the process. So you've got a color match. So the ultimate goal of this is to color match. You've got to understand the customer's needs, and you've got to satisfy those needs. Understand the customer's color expectations, manage them, and work out a match. Now that's actually quite a bit more complicated than it looks, which is why I'm going to bring you onto this slide. Often the customers won't understand their expectations. They just won't know, which is why it's really important for you guys to ask the questions. How important is color? The first thing to ask is, what colors have you got in here? What colors did you want in there? The worst one and the worst customer in the world is a customer that doesn't know what color they want. Oh, any shade of blue will do. That's the worst thing that you could ever hear, because you'll print any shade of blue and then they'll come back saying, oh no, that's not what I was expecting. It's so important to get this done up front. Okay, any shade of blue. Well, what shade of blue? Do you have a particular type of blue? Do you want a dark blue? Do you want a light blue? Do you have a Pantone number for a blue that you want? So in this case, the color, customers that come in and say, I have a Pantone color, and they'll show you the color or they'll give you the Pantone number. That makes life a lot easier because you can just match to that. I've known customers that have printed out an entire set of Pantone colors on their printer. So they've set each Pantone as best they could in their printer and printed it out. It was a mammoth effort, and the poor guy spent a lot of late evenings trying to work this out, but he had a book of every Pantone color on his printer. So he could then flop this out in front of the customer and say, okay, my printer prints that particular color like this. Is that the color you're looking for? And the customer would say, yep, that's sweet, that's what I want. Or no, that's not quite what I want, but I like this one. So quite important there to get this worked out for starters. Not the end of the problem. How many times have you had a customer come in saying, oh, it's Pantone 187C. Yep, that's fine. And then when you print that, they go, that's not the color I was looking at. Well, here it is. And you pull out your color swatch, your Pantone color swatch, and what you printed, and you put the two together and say, that's the color. Oh no, but that's not the color I was looking at. I was looking at it on my monitor. Who has a color matched monitor these days? Nobody. The colors you're seeing on your screen can be way off from the genuine color. So your Pantone Reflex Blue on your screen may not be Pantone Reflex Blue. It could be several shades out. So the first thing you ask, if they say, this is my color, where did you get the color? Did you get it from a color book, or were you looking at it on a screen? Because if they're looking at it on a screen, all bets are off. You might as well just start again from scratch. Really critical, important to get this sorted up front. Are there any fundamental problems with that color? Is the color outside the CMYK gamut? Which is why I like my Pantone book very much. I use Pantone Color Bridge. And the reason I use Pantone Color Bridge is that it gives me the Pantone color and the closest equivalent CMYK. So while the color may not be exact, That's what Bridge reckons is the closest CMYK color. So I would use that if any customer came to me and said, well, this is the color I want, I would pull the Bridge out and say, this is fairly close to what it would look like, because not all those Pantone colors are able to be printed accurately. So that's checking if you're out of gamuts. Get samples of what the customer wants. The best one of all is where the customer brings in a sample of their color. So that way they brought in a shade of whatever. Maybe they're matching it to a cushion or matching it to a paint or whatever it may be. Get a sample of that so you can match it accurately. And there is absolutely nothing wrong with this method. I know a number of you guys that have done this, and I applaud you. There is nothing wrong with you printing out all your media swatches. This case, it's a Roland, but I know that the other printer manufacturers have all got the same things. So you can print your color system library colors. So if your customer can't make up their mind, roll this out onto the desk in front of them and say, pick a color, choose your color. And if they then pick one of these colors, yippee, all problems are solved, because you printed this already. You know you can print it. You know what you've got to do to print that color. Easy. So you can often get the customer, they don't realize that you've just made life much easier for yourself by doing this, but show them these colors and get them to pick one. Might make your life a lot easier. Okay, so your customer's expectations. Agree on the color match. I would really recommend printing a color proof and get the customer to sign it. Once they've signed a color proof, they can't come back and say, oh no, it's not correct, unless you have made a mistake. But if you're matching your own proof, then it will look good and it will be correct. Lamination may change the color. So bear in mind that you've got to really laminate that to make sure it's correct. Every laminate will have a slightly different hue. I know, for example, some of them may be slightly yellow or slightly blue. They will change the color slightly. If they do change the color slightly, laminate it before you get the customer to look at it and sign it. Okay, changing gear again, printer maintenance. Printer maintenance is critical for the quality for consistent printing. I can't tell you what maintenance you need to do with your printer or what maintenance you should be able to do with your printer, but regular maintenance really boils down to cleaning and making sure that that your printer is actually doing what it should correctly. Part of the regular maintenance cycle are the print tests, like the nozzle checks. If you don't know, then get your technician to provide training. I do have to say here, use the correct PPE, eyes and hands. For years, I never bothered, but these days I'm a little bit more, think about this a bit more. So I will make sure, well, I always have my glasses on anyway, but I always make sure I put gloves on when I'm cleaning my printer. Some of the solvents that are used around these can be quite harsh on your skin, and you definitely don't want to get it in your eyes. Make sure you're using the correct cleaning solution and swabs. When we say swabs, don't use cotton buds, use the correct cleaning swabs. They tend to be foam swabs, and they will do a much better job of cleaning. Once again, Rolands, because I've got a Roland, but cleaning around the print heads. That's the print head there, black, blue, magenta, and yellow. Sort of, well, cyan, I should say, black, cyan, magenta, and yellow. And being a Roland, if one head's going to let go, it's always the magenta. You can see all the magenta ink here. So when I'm cleaning around here, I would clean around the edges of the heads, but I would not clean the face of the heads. Don't clean the face of the heads. If you clean the face, then you can end up damaging the nozzles. So clean around all of those. I've seen printers where this is so encrusted because no one knew to clean it that they actually had ink dropping off, ink drops were getting into here, and it was just looked terrible. It's no wonder they had a bad quality print, because the heads were filthy. Now with my solvent printer, I've got wipers and capping stations. The wipers, there are two of them. So as the head comes back, this little piece of rubber will wipe across the head. So this one will wipe the yellow and then the magenta, then the cyan. This one will wipe the magenta and then the black. So these will wipe across the head. So rather than you rubbing across the head with your swab, the wiper is doing that. I always take good care with my wipers. I always make sure there's no ink encrusted on them, because if you get ink encrusted on these, you're dragging dry ink across your head and it could damage it. Now for this solvent printer, these capping stations, when the head comes across and parks itself, this is inside where the heads would stop, these things will pop up and push up against and cover the heads. So this will enclose the head. So when I do a cleaning cycle, this sucks and it will suck ink down through the head, opening up any blocked heads. So that's how the capping stations work. They actually physically suck ink through the heads. The head doesn't pump ink down, these suck ink through. Different manufacturers may have different methods of cleaning, but that's essentially how it works. And you want to just make sure all of this is clean. Okay, troubleshooting. This is a lovely section of what went wrong and why. I get a number of comments from people with this saying, hey, wow, this is really important. Common print problems. The potential causes of problems are the printer settings, the media, or the environment. Those four are usually the causes. Sorry, guys, the media is usually the least of the problems. Of all the print problems, 90% of them will be either your printer, the settings for your printer, or the environment that you're in. Very seldom is it the media itself. So check everything else first before you come running saying, oh, my media is at fault. Make sure that you've got everything else checked first. I'm not just trying to get out of it, but generally the cause is often one of these other three things. And when you're trying to narrow down the possible causes, change one thing at a time. The number of times I've had people say, oh yeah, I made 3 changes and I never quite figured out what worked. One of them worked, who knows? Work one thing at a time and see what works. Okay, banding. We talked about this before. This banding issue, we've seen this picture before. This one, in this case, was caused by the incorrect media feed calibration. Sometimes it could be a heat setting, or it could be a vacuum too high. So if the vacuum's too high and it's not able to pull through correctly, you will get banding. But that's usually the cause of banding, is the feed calibration. Ink spotting. See the spot there and the spot there, usually caused by dirty print heads. And this is one, I got this picture from the customer that had really, really dirty print heads where there was so much ink encrusted around the heads that when it tried to print, the ink was literally just dropping off. So a drop of ink was falling off because the print heads were so dirty. You can also get the ink spotting from ink misting due to poor environment or printer settings. So the ink's being sprayed out and you're getting so much ink misting around that you're actually getting ink droplets building up. Flooding or bleeding. This is caused usually by, in this case, it was actually something different, but usually the print settings are incorrect. So for example, you may have the number of passes, you've got too many passes, you're simply laying down too much ink. The media profile's wrong, or a bad media profile where you're trying to lay down just too much ink here. So rather than putting too many passes down, in this case, you're laying down too much ink. So for the black, instead of printing just the black, you've also got 100% cyan, 100% magenta, 100% yellow, and that 100% black. So usually we'd say the maximum ink lay down usually would be between 120, 150 odd percent, so 250%. In this case, 400%. You've laid down everything you can get, you'll get this. It's like solvent soup. You could swim through the amount of ink that you put on the surface. This is media cockling. These little wrinkles that we see in here is caused by usually poor quality media. We'll see this on the cheap media, on the lower quality stuff, because it doesn't have humidity stable liners. So the liners pick up moisture, and when you try and put it through the printer, as soon as you try and heat it up, the liner's expanding because it's got moisture in it, and it causes these wrinkles. So it's usually caused by the media, or possibly the heat setting too high, or sometimes too low. So sometimes I get people saying, how do I fix this? Well, try increasing the temperature. If that doesn't work, try decreasing the temperature. Both can work. If you decrease the temperature, you may not get these forming. Or if you increase the temperature, you may get it heating out and sitting flat again. So heating or overheating or underheating can actually solve the problem as well. Could also be environmental. You know, your printer's in a very cold environment, a very cold room. That's called cockling, just little wrinkles that you get in there. Now the next one, a head strike. Head strikes usually caused by the media cockling that we saw before, getting bad enough for the head to catch the media. And there's quite a bit of banding in there as well. It's not a very good print, but you can see this thing here is where the media is wrinkled up and the head has come across and hit it. And that head has come across and hit multiple times. I don't like head strikes. I would prefer to have a head crash, which is the next step on. A head crash is where the media has wrinkled up enough or lifted up enough that the head hits it and jams, and it will stop the printer. A head crash will stop the printer from working. It'll shut the printer down. It'll beep and cry and sing and tell you that it's unhappy. And that's a good thing because it means you can get to it straight away. A head strike, if you don't have your eyes open, you can get a head strike and you can end up with problems like this. You can end up damaging the head ultimately if it goes on long enough, or this can happen and it can ruin the great lengths of media without you ever knowing it. Usually it's caused by media cockling, or you've got the head set too low. Next one's media contamination. You can see there, that's what we also call non-wet. You can see where the ink's pulled away from here. It hasn't settled down very nicely. Those are fingerprints. That's where someone's handled the media without gloves on and they've transferred the oil from their fingertips to the media. How many times have you gone off and had a lovely greasy fish and chips for lunch and you haven't washed your hands and then you've handled your roll of media and this sort of thing's happened? This is usually caused by storage and handling, and the operative word there is handling, or could also be poor print room environment. But usually at this case, it's fingerprints. Contamination also could be the print room environment that I talked about before, where they were getting silicon coming in from the car groomer. Surface impressions. That mark there is caused by a roll sitting on a bench. So if you take your roll out of its box and you just leave it sitting on your bench, you'll probably end up with this. We do sometimes see this, and this is actually a media problem as well. And this is the time we stick up a hand and apologize. If we roll a roll too tightly out of the factory, so if we roll it tight on the core and then we stick it in a container and we ship it through the tropics in a container ship and it gets really hot, it will expand. And this mark is caused by the liner of the layer above on the roll, leaving a mark in the soft vinyl of the layer underneath. The trouble with a digital print is that you cannot see it until you've printed it. So you've gone through all of that hassle and you've wasted all that time printing it, and then you see it. Sorry, guys. It's just the way it is. Sometimes you'll get it. We do see this in colored vinyls, but the beauty of that is you'll see it before you do anything with it, and you don't have to use that. You can choose not to use it. But when it's on white, you won't see it until it's printed. Right. The next one, pretty much the last slide, and I'm pretty much where I said I'd finish with 15 minutes to spare. This one's called lightning strike. This was actually taken here. I've got a sample of this, which I hand out in the training session so people can have a look at it. This is a static discharge as the roll unwinds into the printer, generally caused by a poorly earthed printer or an environment with high temperature and low humidity. So for you Cantabrians, this will happen more for you guys than it will for us Aucklanders because it's a lot more humid here in Auckland. So this often happens in dry climates where the temperature's up and you've got quite a bit of static in the roll and your printer is not well earthed. So what can happen here is that as the roll's unwinding, you hear a crackling noise. And that crackling noise is actually static, like a lightning bolt forming and leaving a mark on the vinyl. The trouble is you won't see it till you've printed. You can hear it, but you could look at that and think, yeah, that looks fine. And then you print it and this is what it looks like. With this one, the further we went on, the worse it got. So we started off with just a little bit, but we kept printing just to see what it would do. And it got worse and worse like this. So this is a static discharge. We solved this by changing rolls, because the roll we were using was made in the US in very dry climate, and there was quite a bit of static in the roll, but the customer's machine was not well earthed. So they didn't have very good earthing straps inside the machine. So the earthing pin in the 3-pin plug was not correctly connected to the case. So the earthing pin should be screwed to the case. So when the roll unwinds, the printer will discharge the static to the case and out the earthing pin. And that, with 15 minutes to spare, is that.